This is the screencast for section 10.3, example 2. Now we're going to graph with polar coordinates, review that from pre-calc. Graph all points in the plane that satisfy the given polar equation. So A, r equals 2, the distance from the origin equals 2. So if I think about that, if here's the origin, basically it's like a radius 2. The radius is always 2. That's going to be a circle where all points are 2 units away from the origin. So we'll graph to be a circle. Part B, what if r equals -2? Well, r equals -2 is going to be very similar. The radius is -2. It's just now we're going to start at a different spot. In part A here, at the rotation 0, we were +2, so we started on the positive x-axis. In part B, if our rotation is 0, the r is -2, so we're basically going to start on the negative x-axis. So all points are 2 units away from the origin. These just start graphing in a different quadrant, or actually on a different axis. Part C, theta equals pi/6. So for all points, their rotation has to be theta equals pi/6. Those could be any positive points or any negative points. So all points are on the ray with angle pi/6. And that means negative points will plot in quadrant 3, positives in quadrant 1, but all on this same line. Now try problem number 7. Says graph the set of points whose polar coordinates satisfy the given equation. Now this is r squared equals 4, not r equals 2. So if I think about taking the square root of both sides, basically what that means is all points are either 2 or -2 units away from the origin. So it's going to be a combination of example 2 parts A and B. It's kind of a combo of those. So I put in my calculator in R1, 2, and R2, -2, because I can't graph r squared equals. Found a good window, so I did 0 to 2 pi, and then I knew the radius was 2, so I kept my window appropriate. Now, we'll see as we go on here that graphing these, the graphs become more accurate when you leave a ratio of 3 to 2 with your x's and your y's. So that's why I did -6 to 6 for my x's and -4 to 4 with my y's. So now, as I start graphing, I see this. I have one piece that's graphing, so R1 is graphing 2 units away, but R2 is graphing -2 units away. So like I said, one of them starts at positive x-axis, the other one starts at the negative x-axis. And then finally the full rotation would look like that, where really we have a thin one and a thick one because we rotated over 2 pi. We only need to rotate over pi though, because the +2 would cover the top half of the circle, the -2 would cover the bottom half of the circle.